In this video, I will show how to solve an applied problem to find the total cost using the antiderivatives. So the idea here is that the marginal cost is given, but the relation between the marginal cost and the total cost is the marginal cost equals to the derivative of the total cost. So in our problem, the marginal cost is given, and it is equal to this function. So to find the cost function, we have to find the antiderivative of the marginal cost. So if we're looking for the cost function, we're going to set it up like this. Now to find the antiderivative of this function, we're going to use the properties of antiderivatives, and we're going to split this integral into two. And I'm also factored the constant out to make the integration easier. So antiderivative of 10 is simply 10x, and antiderivative of x squared is 1/3 x to the power 3. Now, since this is an indefinite integral, we also have to add a constant, and since letter c is already reserved for the name of the function, I'm going to use letter k. Now, to find the value for k that will satisfy all the initial conditions, we have to interpret the last statement here. So what does it mean that the fixed cost is equal to 100,000? The fixed cost equals 100,000 means the cost of producing nothing is 100,000. So that means if I plug in 0 into my cost function, I will get exactly 100,000. So from here we conclude that the constant of integration is 100,000. So now I have the cost function, and we can put x cubed here in the numerator. So this is my cost function that satisfies all the given conditions. And to answer the question, I just have to find, that is to find the cost of producing 100 boxes. That means I have to find C evaluated at 100. So simplifying everything here, what do we have? 10 times 100 is 1000. 100 cubed is 1 million. 1 million divided by 300,000 is so reducing all the zeros, it's same as 10/3. So basically the answer is 101,000 and $3, and if we round to hundreds, 33 cents. So this is the total cost of producing 100 boxes of DVDs according to the given marginal cost function.